How are you? I'm Gary Ryan. I'm going to do my own introduction, as it turns out. And in some places you might have seen the title of the talk for the evening was going to be on running performance, and some of it is. But I'm actually going to broaden it out and talk a little bit about some other sports and some things that maybe you covered in some of the previous talks. So just to introduce myself, for want of it, my ego gets out of control sometimes. As a student, I studied, I have a master's degree in biomechanics from the University of Limerick, and I lectured there for a while. I then went from there to be, after I retired as a track athlete, I competed at 2 Olympics in the 200 metres and the 4x1. I was director of coaching for Athletics Ireland, and I was the high performance manager for a while. And I'm now a coach of athletics as well. The one thing I most definitely am not is an engineer. So the perspective I'm going to take really is the one that I know best, which is the end user, if you like, the person who's going to use the wonderful solutions that you guys can come up with. So I'm going to look at this maybe from what can GPS do for me as a coach? What kind of questions do I have, and what are the kind of uses that coaches are using it for it now? And what might we be able to use it for in the future? What I'm doing here right now is I work for NUI Galway as the development officer for elite sports. So I work with some of the elite teams like the Gaelic football team, hurlers, throwers, basketballers, and then with 60 people that are on sports scholarship. So that kind of presents its own challenges because you have to think very deeply sometimes about a sport. So for example, I do strength and conditioning with some people, and I've got an archer and a kickboxer. Now how do you make a strength and conditioning program for an archer that's specific to their sport? And you really have to spend some time thinking about it, because the contractions, for example, in that sport and the muscular contractions that we're talking about are quite different to what you'd normally do in athletics or in tennis or in football. And you have to think quite long and hard about it. And that's what I would say to you. My one message at the beginning of this is, as engineers, if you're thinking of solutions for sport, try and think very deeply about what the end user is going to want that solution for. I'm mainly going to focus on GPS. That's a schematic of what GPS is. It's satellites. It sends a signal down to a receiver on Earth. It sends a signal back to the satellites. You know far more about that than I do. But it is a technology that's beginning to pervade all of us, because it is something that we use every day. The GPS units that you might have seen already in Liam Kilmartin's talk, I think he showed you one of these. This is one of the units. So this is something like the one on the right. This is one from VX Sports. So these are ones that, for example, you put in a pouch or in a vest that, for example, rugby players or Gaelic footballers will use and wear underneath their training kit. And then this is the one I'm going to talk about a little bit later, which are GPS watches, which are becoming more and more popular. Garmin are probably the leading manufacturer of them. And I'll also kind of have a little talk about your smartphone, because this is the technology that will probably, in terms of sport, change a lot of, particularly participation sport in the future, I think. As we go along, by the way, if you want to ask a question or anything like that, this is just a chat, I suppose, and I haven't lectured in a while, so bear with me. The information from the units, if you don't know, I presume you probably know most of this already, it's coordinates. So you get a position on Earth, and then because you change position, it's able to calculate your acceleration, your velocity. Most of these units have got an accelerometer in them, and that means you can work out things like impacts, so the deceleration, the acceleration profiles of athletes. Most units are now sold with heart rate monitors, because that's a particularly useful piece of hardware, because if you can link what's happening when you're running at a particular pace to your physiologically. So I'll talk about that a little bit later as well. A lot of this talk is going to be on taking some of the information that you've seen already possibly in one of these talks and saying, well, what would a coach do with this? What does it mean to a coach? And then going from there. And then I'll actually go back to my own sport, athletics, and say what GPS is doing right now in athletics and what it could do in the future. And when Gerard asked me to to maybe do one of these talks, you know, sometimes you kind of go, oh, what did I say yes to? Why did I do that? And but it's been very useful for me because I've been working as a coach with some high-performance athletes, and we've had some problems that are very difficult to solve, and I'll show you what the problems are. We'll go as a case study. And some solutions came to me when I was preparing this presentation as to some possible things that if you tweak the hardware or the software, we might be able to do something for these athletes. The great thing about GPS is its lack of intrusion. You know what I mean? It's something that, like this, is very lightweight. It's easy break. And you can wear it. And if you're wearing it, you've worn these, Kevin. You wouldn't notice after a while that you're wearing them, particularly in the vests. You know, GPS watches, again, you certainly don't notice that you're wearing them. I'll come to later talking about testing and athletics and how it's not normal, some of the testing situations you put athletes into. So you're not getting real data. You're not getting a real picture of what that athlete is really like. You can use it in real game situations. Now, currently, the rules of all sports are you can't wear these in actual competitive games. In the same way that in Gaelic football, rugby, soccer, you can't wear rings or any hard jewellery, you're not supposed to wear these. Now, some teams secretly do. It is against the rules of the game. But as these become, I think as the units evolve and as you might not need the accelerometers, you might just use the GPS unit, for example, they'll get smaller and they'll become, I think, eventually, I don't know the technology and the circuitry that's involved, but maybe they'll eventually become part of a jersey or an Under Armour or something like that. The great thing about GPS is because it's time-stamped, it's very easy to combine it with other technologies. So particularly with heart rate monitors, with the accelerometers, and I'll talk about other things that I think in the future it might be linked with. That makes it very, very useful, even though it's very, very simple. And it's an everyday technology because, you know, it's in your phone and it's in your car. Now, it's a very simple technology in some ways because as someone once described it to me, it's really just a fancy stopwatch or it's a really fancy map. So, but in the same way that a car is a fancy horse and cart, it is really us evolving and making things a little bit more user-friendly, a little bit faster, a little bit more capable of dealing with large amounts of data. I'm going to talk to you a lot about information, which is the key thing to a coach at the highest level. And GPS is very good at collecting it and keeping it. So what a coach can learn from the GPS units, distance travels, the speeds attained, the acceleration, deceleration profiles of the athlete. Those things are incredibly important in terms of putting it back into what the training should look like, what the performance is. So you're getting two aspects of it. Well, how is somebody doing? And how much better can they do? And performance profiling is, again, something that I'm going to keep coming back to. If you know how fast someone's moving, you really want to know how is that affecting them. So I think anybody here watch Operation Transformation? Anybody see that program? And they did it a bit at the beginning where they had the poor people run 200 meters in the Phoenix Park at the beginning. And they told them to sprint as fast as they could. And none of them got 200 meters. And the reason they did that was because the intensity level was so high that they weren't likely to get there anyway. And they came back about 6 weeks later and they said, well, you can run 5K, but they said run it really, really slowly. So it was much easier for them to do. It was a bit of a trick. So your heart rate level is the thing that determines how much you can do. And if you can match that with the speed that you're doing it at, then you get an understanding of the workload that you're capable of doing. Impacts that the accelerometers in the GPS units measure. Really important in sports, for example, like rugby. And that's determined a lot of the strength and conditioning that rugby does now. And if you look at this, there's been a lot of studies in America with American football and the impacts that players are suffering because of the padding that players are wearing. So now they're having to rethink, well, the injuries and concussions in American football that they have because of the padding, it's being used as an offensive weapon. So they've measured it with GPS units and accelerometers, the speed that the contacts are happening and the force of the contacts has meant that because the players are getting faster with better conditioning, the impacts are getting bigger. Same with rugby. They've had to obviously develop a great deal of body mass to cope with the impacts that they suffer in games. And looking at the cumulative impacts and the body load that's on someone. And I'll talk a little bit about that in terms of maybe GAA and how we could possibly use GPS to help manage that a little bit. What can a coach do with this data? So just some of the things that I would say you could easily do is risk assessment. So sending an athlete who's not well enough conditioned into an environment where there's high impacts. If you're sending them back from injury. So we would have people that I work with right now that are coming back from long-term injuries. So you want to manage them coming back slowly. You want to say, well, you can't go beyond 8,000 meters in a week and you can't go above 20 kilometers per hour in the speed of your running because the risks start to go up, things like that. That's how GPS can manage those situations for people. It can also assess the level of impacts, as I was saying. So if you're, again, rugby is a great example. You know, you wouldn't put someone into an environment where they're going to get injured. You can use it to assess match fitness. So are they covering the amount of distance that you would expect from someone in that position at this time of the year? You can use it as comparative data to, well, what were they doing this time last year? Are they back to full fitness in a training session? You can use it, and I'll show you the kind of things you talk about in terms of designing training sessions and what's important. So how can GPS feed back into your knowledge about how you're going to structure a training session? Training periodization is the key thing in long-term performance. Have you done anything on periodization in training the people in the sports course? It's how you structure a year, and I'll show you one of my long-term plans for one of my athletes later. Just a glimpse of it and the kind of detail that you have to go into, because developing performance in sport, and particularly in running, is how you build blocks of training together. And it goes from a rest state to Olympic level. So it's how are you going to get someone to peak? You've heard of peaking and tapering and all of that. And so how you manage periods in a training cycle over a year, over 4 years, is really crucial. That's how you develop performance. You can't just keep doing the same thing. You have to have building blocks in it. And indeed, there are some teams that use it for selection. And more, for example, I was at has anybody at ice hockey games? The thing, and I know nothing. There's a North American here, they're going to tell me I'm crazy. But I was at the Belfast Giants a few weeks ago, and I just couldn't understand. The interchange is amazing. They do it so quickly and so often. There's a suggestion that in some sports that with GPS units, if you track someone on a GPS unit, you'll be able to make a judgment decision when to substitute them or when to go for an interchange. I know Aussie Rules do it a lot in pre-season, that they take players out when they're beginning to show higher levels of fatigue. And it's a good way and I know that some of the rugby teams do it in their pre-season training and in practice games, that they change players out because the higher you fatigue, there's lots of studies that show the more fatigue that you have, the risk of injury becomes much, much higher. So again, trying to manage those situations. Right, I'll have a little bit of a rant, I suppose. As an end user, as a coach, I think one of the things, and I learned this probably the hard way as a student, I did my master's in biomechanics and was on the kinematics of running. And we used video technology, which the video technology was the kind of stuff you'd find on Noah's Ark, really. It was very ancient and very slow and very cumbersome, but we generated an enormous amount of data. When I went back to feed it back to the coaches and the athletes that volunteered for the study, a hell of a lot of it was pretty irrelevant to what they were doing. So if you're communicating with coaches or end users of whatever product or solution that you come up with, you've got to think, how relevant is this information? So in athletics, how relevant is the angle of, so I had angles, for example, at the hips. Well, some of that's relevant. Angle at the knee, very relevant. Contact time, very relevant. Height above ground, not so much. So I was delivering them a lot of data. 50% of it was rubbish, and they probably didn't buy into all of it then. So that was a big lesson for me when I was just doing the feedback with them. As a coach, we would use a lot of video technology with national teams and things like that. And now it's getting better and better, but a lot of the studies that we've done with students and with PhDs and people like that who've helped out our national teams, it takes a long time for the data to come back to athletes. And training cycles are usually 4 weeks. And if you've gone out of that training cycle, you're not going to be able to affect it too much. And it might be a month or 2 months before you get the data back. So a coach needs fairly instant, if not instantaneous, data to come back. So real-time data is fantastic. So if you're able to see something happening and change it, that is a really valuable tool to a coach, even if it's not as accurate as a lab condition, if you understand what I'm saying. So sometimes coaches would prefer to sacrifice the accuracy for getting the data quicker. And GPS is one very good example of that, because GPS, as you probably know, isn't massively accurate. I'm open to correction, but I think it's sampled at about 50 hertz. So 50 hertz is reasonable. In athletics terms, it's the difference of about 0.2 over 200 meters on a stopwatch, which is about the same as the difference, you know, a manual stopwatch, when you have a stopwatch in your hand and you're timing someone, to what they have electronic timing, which is accurate to 1,000th of a second. So it's reasonably accurate, not incredibly accurate, but it's very, very good at giving you data back straight away. Can I understand it? Well, what do I mean by that? You've got to understand that a lot of coaches may not be engineers or biomechanists or physiologists. They are people who started coaching in clubs or coaching their own kids and things like that. And they really need to have it put in a language and a format that they understand, is clear and very simple to use. Sometimes you see graphs or feedback that comes from software that really isn't. We've got a particularly good piece of equipment here called an OptiJump. The software in it is brilliant, but it isn't very good for coaches. I think if they tweaked it a little bit, it would look better. So if a coach saw red line or red flashing beams or biofeedback systems that use beeps, you know, things like that. Very simple stuff that kind of goes, right, I can understand that. And if I do this, what will happen? That kind of simple input and output. They are really anxious to understand what difference will this make. If I was to change what you say is wrong, what difference will it make to my athlete's performance? So I'm going to go through some just little bits of GPS data and say, well, how this will affect the athlete. And probably most importantly now, I've found as a coach, is how do you use the technology and the information that you have to communicate it back to an athlete? And I'm just using this as all background when I talk about GPS in particular, but I think as a general thing about technology, technology is brilliant, but how do you get that information to the actual end user, the athlete? Because we've kind of changed as a society. The kind of ways that we learn, I think, are different. You guys are, there's even a generation between you and me in terms of the technology and how we learn. One of the greatest lessons to me was when I was director of coaching for athletics. We took a group of 15 to 19-year-olds to Poland for a training camp. And these are the best, these what we call our 2016 group, the guys that will be competing in Rio in the Olympics. And, you know, none of them had ever been really exposed to any sports science. But we took a sports scientist with us to try and educate them about the things that they could do and could learn. And we took a particularly good piece of hardware called, I've forgotten it now. It's a sensormatic thing. It's a body sensor. So it measures your things like your sleep, your use of calories, the intensity of the workload that you do during the day, things like your hydration. We did all those things. And it was something they wore for 24 hours. And then they get lovely little drawings and graphs and sort of pictures of what they should do and shouldn't do in a very simple piece of software. And we'd do it, they'd wear it for 24 hours and they'd give it back, and the sports scientists would sit down and show them the little pictures and graphs and stuff like that, of what you need to do more of, what you need to do less of. And things like they didn't know that they were doing was, for example, middle distance runners will eat like horses, but they won't eat enough. You got to understand that the average 18-year-old middle distance runner is probably using around 4,500 to 5,000 calories a day. Most of them were probably taking in around 3,500. So we had 35 girls there it was great news to them that we could say you can actually eat almost twice as much as what you're eating right now. And it's really important to try and it was a huge impact on a lot of young athletes and how we were able to communicate it. And we used a lot of video, we used a lot of, Bolton, for example, put everything onto iPhones if they're trying to communicate stuff to the players. The coaches gave up drawing stuff on boards some years ago, and they put all the set pieces, all of the instructions on iPhones, and you see them looking at the iPhones and not listening to the coaches before the games. It's a little strange, but training for performance. The things that in a training session you're trying to manipulate: intensity, volume, rest, and time. They're the things that you manipulate to improve performance. They're the key things. There's other little things you can do, but they are the key things in making someone better. In a training program, you're looking at things like, how specific is it? There isn't much point in a swimmer running. There isn't much point in a weightlifter doing a low-intensity yoga. Well, there is a little bit, but not a lot. There isn't. Footballers have to practice kicking. They have to do the intensity level of what they're training, they're running at the right level. I'm going to talk about that in a second. There has to be a certain amount of variability in what you do as well. So that you can't just keep doing the same thing every day. That's what they call burnout. It's a mental, physical, real state. So you have to vary the training, but it still has to be relevant to what you're doing as a sport. This is the key thing that people tend to be very bad at, which is overload. When I say overload, if I was to say that to a group of coaches, they would go, right, overload means I do more every single day for the next 25 years. It isn't. It's controlled overload, which means you do. So, for example, in the training programs I do with my athletes, they're on four 4-week cycles at the moment. And each 4 weeks, they get a rest week. So each week gets harder, 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 and the fourth week is easier. Harder, 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 easier. And it's in the recovery times, and the same happens within each week as well. Within the recovery times, that's when you improve, because training is actually bad for you. And it's the body's reaction to the physiological demands that training gives you is when you improve. So managing that is incredibly important. And again, GPS could be a great way of managing that in athletics in particular. And there's the use it or lose it principle called reversibility. So if you don't train, you'll lose what you've built up. You'll lose your aerobic capacity. You'll lose your maximum strength. You'll lose your elastic strength. And that can happen in some ways very quickly, in others very slowly. You lose about 10% of your VO2 max, your oxygen uptake, in about 3 months, which is not a lot. But within a week, you can also lose a certain amount of your maximum strength. So you have to keep doing something, and it's about controlling that progression. And again, coming back to GPS, it can be a very useful tool on a day-to-day basis for controlling progressions. So I'm just going to talk very quickly, sorry, I've been waffling, about team games. So I know that Liam Martin in a previous talk showed you some of these, thanks to Kevin. And I know this is just an example. So this is from a game, I think. Yeah. So if you just look, the one thing this is Gaelic football. And the thing that kind of jumped out at me when I looked at this first, anybody, can you see that? So the blue is the slowest, green is the next speed, yellow, orange, red's the fastest. Anything jump out at you? For Gaelic football, the thing that jumped out at me anyway, was that half your time is spent doing nothing, essentially. You're going at 0 to 5 kilometers an hour, which is walking or standing. In a game where Kevin covered about 7.5K, which is about right for what a half forward would be doing. So half that time is spent in rest. A quarter of the time is spent at what I call jogging pace. So that's zone 2 is 5 to 10 kilometers per hour, which anybody here run? That's about a 6-minute kilometer pace. Not that fast. It's reasonably okay jogging. Okay, so you're jogging for a quarter of the time. You're standing or walking for half the time. So you're only doing something reasonably fast for a quarter of the time. and you're only doing something very fast for a very small amount of time. This is a training session. So then if you go back and you match what your game data, you should be at least matching that in training. And here's a training session with far more rest time in it. Now, the good thing about it was there was a greater degree of faster work in it. But here's where GPS can be very, very useful, is to match what you're doing in training with the demands of the game. So if you're resting too much in training, you're not going to be able to sustain it in a game. You get it? So using that kind of data is really, really important. Again, it's taking out probably less into the jogging part of it. So a lot of football is at a low intensity level, which is very interesting. Now you have to think, when you have the ball, what are you doing then? So this should dictate the kind of training sessions that, and I don't think that happens. I don't think anyone sits down and structures their training like they should. For example, what you should be thinking of is what of the ratio to work rest, and that's in any game. So if you took this for tennis, if you looked at that for a tennis player, well, what's the ratio of work to rest? That's really, really important. You know, at least 75% of the time that you have available to you in Gaelic football is spent walking or running. The critical work you probably do is the things you do at the highest speeds. If you ever watch really good performers in sport, the difference is they're able to do skills at high speed. So matching that, you need more data, obviously. Matching what you do on the GPS with video technology will be really, really useful. So it says, if you executed a skill, what speed did you execute it at, and what was the result of the action? So matching GPS and video, which is possible to do, or match analysis, is really, really useful. Now, again, you can also manipulate game tactics. If we were to go back here and say, well, we know that the team that we're playing against, that they've prepared and that they will do what the normal thing is, that half the time that in their preparation, their training, is going to be rest. They're working at a rest to work ratio of 1-to-1. If we go at a rest to work ratio, which is maybe 1.25 to 0.75, something like that, well then we can actually tire them really quickly. So I'll go back to my early days. I was a soccer player. And we had a really good coach. There's nobody here that will remember a guy called Billy Hamilton who played for Northern Ireland in the 1982 World Cup, except me. And he was our coach when I was a kid. And I used to play up front. And he basically told me that if a guy was as fast as me, if the guy was slower than me, I was to stand still and run past him every time I got the ball. If he was faster than me, I was to run him all over the place the whole day until he tired out and then run past him. Or that we could bring on a substitute and he could run past him. So you can manipulate tactics as well if you understand what's going on in a game and you understand that from GPS data. And you get a better idea, obviously, of your own players and what their capabilities are if you were to put GPS on them all the time in training sessions. The other thing that I found interesting when I looked at this was, you probably can't see it there, but this is a record of all the runs that Kevin did in that game. And the interesting thing about it is the vast majority of them, the farthest run in the whole game was 60 meters. The vast majority of them were between about 15 and 30. So Gaelic footballers running 200 meters or 300 or 400 in training isn't really that useful. It can build up their aerobic endurance a little bit, but what they really need is fast, repeated work. It also is really interesting if you go through all of these, which you won't be able to see, is that it tended to happen in 30-second bouts. So we'd run, have a quick rest of about 3 or 4 seconds, have to run again for 3 or 4 seconds and a rest of 3 or 4 seconds, run for 5 seconds, rest for 2 or 3, and then might get a minute or so of a break. It tended to happen if you go through this, and this kind of follows up what I always kind of believed about Gaelic football, that it's bouts of 30 seconds of really high intensity work followed by long periods of rest, which would be similar to something like rugby, which is probably longer periods of work and longer periods of rest. Hurling, completely different. Hurling is a completely different game, and the training for both of them is completely different because hurling is much more even longer periods of rest and higher intensity work. So you're going from a standing to a sprint to collect a ball and that. But Gaelic football, there's a lot more movement of the ball up the pitch. There's a lot more off the ball running, which isn't in hurling. Gaelic football is much more soccer and rugby. That's my belief anyway, and I think the GPS that I've seen kind of backs that up a bit. Now that's all got to feed back into the conditioning of the players. So very little work is done at the highest speeds. It's 30 seconds of high intensity activity, and you can work from 1-to-1 to 3-to-1 rest ratios. And the quick recovery is crucial in most sports, but particularly in Gaelic football. Just again, I don't know if it's not very clear here because of the lights, but I just kind of, because I'm boring when I was looking at this kind of stuff, it's interesting because we would do a lot of drills running through poles or over cones or whatever. Anybody, how many of you play football or hurling or soccer? Okay. And you probably do all the drills and running drills in between cones and stuff like that. Most of the runs in Kevin here, and this would, again, bear out things that I've observed, were in straight lines. The vast majority were in straight lines. So that's one thing. This is all of his runs in that game. The interesting thing about this is, unlike hurling, Gaelic football, you're moving a lot more and you're moving onto pace. So in hurling, it's from static and you're starting from a standing position a lot of the time to go to the ball. Whereas in Gaelic football, you probably have a warning. You're moving onto a ball. So you're probably starting to walk, jog, then sprint. And that again goes back into the specifics of training. You wouldn't do as much of a standing start in training as you would on what we call a rolling start. So just really small, but really they're the things that make the difference. High performance is 2%. The difference between the gold medal in the Olympic Games at the 100 meters and not qualifying to go to the Olympics is less than 5%. That's the difference we're talking about. Somebody who won't even get on the plane to London is 5% behind the gold medal. We're talking about very small margins. I'll keep going because I want to talk about myself. And just a quick one. One of the things that in my current job, we have a lot of players that play for us here in the college. They play for their under-21 county team. They play for their club team. They play for the county senior team. And one of the big topics at the moment in GAA is burnout. And people talk about, what's burnout? And I notice it a lot. The players get very tired very quickly. And the reason I think is because they're playing for multiple teams and multiple coaches. They tend to be doing a lot of the same thing over and over and over again at very similar speeds, at very similar intensities. So they might do 3 of the same sessions with 3 different teams in the same week. And they play a lot of games, and there's no record of what they do. Every one of my athletes, I have a record of everything that they do. One coach should have that. I know exactly what distance they've covered, how much time they've covered, or I should, I'm going to talk about that in a second. But nobody has that of a Gaelic footballer, not even the Gaelic footballers themselves. Nobody sits down and plans the session and knows how much work they've done at what intensity levels. And that leads to physical burnout, higher incidence of injury. If every GAA player in the country had a GPS unit every time they trained, you could actually store that data centrally and you would have the answers. And I think it would be a great study for someone to do, to examine that, to say, well, what is the total amount of volume that these guys are doing at the highest level and how can you manage it? May never happen, but I think it's a really interesting one. All right, athletics. Finally got there. Athletics and GPS is becoming really, really important in it, particularly in distance running. And this is a heart rate chart. I'm sure some of you see these or they're on bikes in the gym or whatever. And understanding what zone you're training in is incredibly important. That was just, in the past, something people guessed. Run as you feel. In recent years, more and more people started to use heart rate monitors. Heart rate monitors are pretty good. They're not the be-all and end-all. They have their own little problems and stuff like that. One of the interesting lessons, going back to what we did with those kids in Poland years ago, was most of them had never used a heart rate monitor. And we gave all the ones who'd never used a heart rate monitor a heart rate monitor. And their coaches, when I say how they manage their training, would be, for example, in a week, they would have an easy run, which was meant to be kind of a recovery thing. And they would have a hard run, which was their aerobic development run, if you want to call it that. The easy run should be sort of around 140 beats per minute. The hard run should be around 180, 185, 190. we put the heart rate monitors on from a week and just told them to run. We downloaded the data. And we found that their easy runs were always run too hard, and the hard runs were always run too easy. So by using a simple piece of technology, their performances improved a lot when they actually went home and bought a heart rate monitor. And it's just that little bit of education. The GPS, I think, can do a lot more if you combine it with heart rate monitors. I think now it's going to become an essential part of your kit as a runner. Heart rate monitor, GPS, and blood lactates. Blood lactate is really what a heart rate monitor is trying to find out at the end of the day, is your level of lactate and where you start to produce it. GPS watches now can measure, obviously, the time, the distance, the pace. There's a nice one out right now that can be your training partner because it's given biofeedback. And when I say biofeedback, it beeps if you're going too fast or beeps if you're going too slow, or it can be, it beeps if you've reached the point where you were in your last run, things like that. There's a lot of little gadgets right now that are doing that. And it can be very, very useful. But it's all designed around the distance runner, which I'm a sprint coach. So I feel left out a little bit. The greatest race I ever saw was a race in the 2000 Olympics. It was obviously 28 guys in the race, but it ended up, the gold medal was won by a guy called Haile Gebrselassie from Ethiopia, and silver was Paul Tergat from Kenya. And Tergat would have been a real cross-country runner and Gebrselassie track runner. Gebrselassie, after 10,000 meters, won by 0.09 of a second, which is nothing. But all through the race, Tergat tried this tactic that the Kenyans have called surging. So the lap times were never the same. Like they ranged from, during the race, from 63 seconds to up to 67. And in a 10K, that's fair moving along. The last one was running 54, which is incredible. But in that, what you wouldn't have known by using a simple stopwatch, is that Tergat would run a 400 meters fast, slow, fast, slow, fast, slow, fast, slow, maybe 20 meters bouts. And what he was trying to do was mess with everybody's heart rate between it. And you see this at the beginning of a lot of races where guys are just getting tailed off very quickly. Even though they're not, the kilometer times aren't particularly fast. It's because the guy at the front is speeding up and slowing down, speeding up and slowing down. And the heart rate is just going crazy. And they haven't prepared or trained for that. And the African athletes are used to it because they naturally do that. That's the way they run. They go out and they run very free and they don't run. Whereas European athletes do this traditional even-paced interval sessions. I'll do 12 by 464 seconds, and their heart rate is building slowly but very constantly. So they're not used to when someone changes this. And the easy, hard, and the tempo. Some fartlek is that idea of changing pace, but they don't do enough of it. What GPS might be able to do is you can send the athlete out, get them to change the pace with an instruction on their arm, just a biofeedback, again a beep or something like that, or vibration, and they can change pace and do what will be expected of them in a race. It's very difficult to do on the side of the track saying go faster or go slower. But it'll also come back to the coach and you're able to download it and see, well, did you actually do it? The era is going to be about lactate thresholds, pace intervals, things like that, changing the way we train. And it's beginning to happen. But you'll see in the Olympics in London, there won't be a single European athlete of European descent in the final in the 10,000 meters, and there won't be probably anybody in the top 12 in the marathon. There will be some Europeans because there's some of African descent who grew up learning how to run that way. There will be some Americans possibly because the Americans have started to train in this way in a thing called the Nike Project in the States, and they've changed the way they train and learned about how to manage pace and do things like that. I think the great future in terms of engineering is the mass market. And I don't know if anybody has any of these. I've got this on my phone. It's Nike Plus. There's loads of them. There's Endemode. There's ones for cycling. They're all GPS units, and there's a strap that you can strap on your arm, and it gives you how fast you run, your kilometer pace. It has a really annoying guy that comes on and tells you to run faster. There's some great jab, that kind of stuff. And it's just, this is what people want. There's going to be 16,000 people running in the Dublin Marathon. There's 20,000 women that run the mini marathon. Huge numbers of people involved in recreational running and training. It is in our area of tightening our belt gym memberships are getting cancelled, and if you go out this evening, Monday evenings in Galway, you'll see a thing called Fit for Life, and there are thousands of people out jogging. It's transformed. But they'll all want to have something that's their competition. And something like this, these are goals that you can set for yourself and you record it. So I've got on this, it keeps all of my runs. Every run that I've ever run with this thing is on it, which is really painful for me because it's really slow. And it's like, oh God, have I come to that? But it's a great way of keeping information. And that's the thing, I suppose, about technology. I know that you talked about the bikes, the track bikes, and the limits that are allowed on track bikes now. So they have banned some of the bikes that they can use in the Olympics and track cycling. And the same in swimming, that the shark suits aren't allowed anymore. I love that picture. But that's the thing. Eventually, if you design something, even running shoes, the spikes that we use in track athletics, there are very, very strict limitations on what you can do with them. But the one thing that you can't change or you won't be able to control is information. And the crucial information, recording and keeping it, GPS is very good for that because you can just download it to a laptop and you keep it. Remote coaching I'll talk about in a minute. It's real and it's accurate information that you're getting, because sometimes if you use a stopwatch, you should come up and watch me coaching and I'll be talking to the athletes and and I'll miss the start or I'll miss the end, and I'd prefer if I had a GPS unit on each of them where it was remotely started or automatically started and I didn't have to be timing them, because I can concentrate on them and give them proper feedback. You know what I mean? Just simple things. And that I would be able to, because I'm terrible as well at writing down in diaries, and they're worse at writing down in diaries what the times were that they did for training. And I'll have 12 people on the track tomorrow, and I won't be able to record all that data. So if everybody had a GPS unit and we logged it all, I'd have all that information. And a diary is the key thing to developing someone's performance. This is just a talk about planning. This is one athlete's plan for a year, and the different colors of the intensity levels that they work at, the shaded areas are the weeks that they have easy weeks. There's a lot more data, test results go in there, stuff like that. This is page 1 of 24 pages that they'd have in their diary, or in my diary, of keeping a log of what they do. And we keep every single training session over every year. And that's how we're able to improve them. But sometimes that information isn't complete or may not be accurate. And that's, I'll talk about that in a second. This is the king of the world right now. So Usain Bolt, the fastest man alive, I suppose, in some ways. And I'm just, for the sheer hell of it, going to talk about profiling. What you're trying to do is build up a profile of your athlete. And this is him setting the world record of 9.69, or 9.68, in Beijing in the Olympics in 2008. And it was just an incredible performance at the time because of this bit. Because he looks like, I'm just slowing down, it's really easy. This is the time velocity graph of that performance. You think about it, there's his maximum speed there, 43.9 kilometers per hour. I was out on my bike, I have a road bike, and was out on the weekend. I couldn't even get to 40 on the bike, which is very distressing. And I'll go through how this relates to training in a second. This is Bolt a year later in Berlin, in the World Championships, when he broke the world record again in 9.58. And his manager is a guy from Donegal. And trust me, the manager had a word in his ear and said, you cannot slow down getting to that finish. We want to find out what you can do. And what he could do was 44.72 was his peak speed. Now, if you just look at this graph, this part is the acceleration phase. This part is your maximum speed phase, and this part is you want to call it your speed endurance phase. And they have huge impacts on your training. And I'll talk about that again in a moment. You could measure all this with laser, with radar, with timing gates, with a thing called an optojump. But they're all very expensive. Timing gates, less expensive, but hugely awkward. Laser, really accurate, but very expensive, needs a skilled operator, can't do anything around bends, things like that. Whereas GPS can do whatever distance, it's easy use, the feedback comes back instantly from it, you just stick it on someone, they don't even know they're doing it. Laser, timing gates, people know that they're in a tested environment, and it changes their approach anyway. But it's much easier to stick a GPS unit or a GPS watch on someone and get your feedback that way. What you really want is not something that you find out every 3 months, but something you find out every day. And what you're looking at is reaction, acceleration, max velocity, and the training things that go into that. And I'll just talk about them. This bit, the acceleration bit, it's all about maximum strength, what you call the slow stretch shortening cycle. So the kind of, if you can imagine, when I was running 75 kilos, trying to move 75 kilos from 0 to maximum speed. So you're trying to move a dead weight really quickly. That's what you call your slow stretch shortening cycle. Slow speed, slow strength. It's your maximum strength. So if that's not great, if the line of the graph here is too shallow, you go back and you work on your slow stretch shortening cycle in terms of your training. You change your weights. This bit and your technique from the start of it. This bit, your maximum speed bit, has much more to do with the nervous system and your elastic strength. So the nervous system is learning and the technical work. So it's really about the technique that you have and levers and the point of contact with the ground. So you go back and you would spend more time. If that's not great, if your maximum speed is not great, you spend a lot more time doing elastic work, plyometric work, speed work in terms of flying runs, things like that, maximum speed velocity stuff, which is very hard in your nervous system and you don't have as much, you can't do as much of it. But again, it's informative back to your training. And this bit that most people hate is the speed endurance work, but it's also the crucial bit. Because if you lose 3 kilometers an hour in the last bit of the race. So if you look at Bolt going back there, it looked like he was running away from everybody. He actually wasn't accelerating in most of those races. It was everybody else was slowing down a lot quicker than him, which is an interesting, him and the guy who was second in the Olympics, Tyson Gay, are both 200 and have run 400s as well. The guy who was third, Asafa Powell, probably quicker than Bolt over 30 and 40 meters, but wouldn't run a 200 to save his life. And the change in the world records is because the guys like Bolt, Bolt was a 400-meter runner as a kid. Phenomenal talent at 15. And he has enormous speed endurance. He's able to maintain his top speed for much longer than anyone else. He's not the fastest man ever, because Donovan Bailey ran something like 46 kilometers per hour in a race in the early 90s, I think. But Donovan Bailey was very slow over 200 meters. He couldn't sustain it. He peaked and his speed endurance dropped very much. So coming back to my training and what GPS could tell me, if I could build up this profile on every single run in every week, then I'd know how my training was going with my athletes on their slow stretch shortening cycle, on their technical work out of the blocks, on their maximum speed work, on their speed endurance, on their plyometric work. I would have testing results every single day, and this would be applied rather than taking them into a lab or into doing a test. For example, there isn't really a power test for athletics. There's a thing called a Wingate test on a bike, which is as useful as a chocolate teapot, really. You can do vertical jump testing, but again, doesn't take into account technique. If you could build up a graph like this on every single session, you would have enormous amounts of information that you could use and develop your training. But if you only do it once every 6 months or 3 months, then it's not much use. So GPS is the thing that will change athletics, I think, through this, because the data will make such a difference. I might just skip this. Relays, I was going to explain how you could use GPS. One of the things that occurred to me is if you put a GPS chip in a relay baton. So relay batons, the whole point of a relay is so that the relay baton, do you ever watch, I'll just play it while I'm talking. If you never watched a relay, is to keep the relay baton moving as fast as you possibly can. So what you don't want to do is it, as it's exchanged, to slow down. So you'll see, if you watch the Olympics, the Americans, watch them, they'll make an arse of it. So, sorry, shouldn't say that. They will, the guy will go off at the wrong time, the guy will run in and slow down, the guy will go off too early. There's lots of things you can do. If you knew the profile of the athlete coming in and the athlete going out, so that drawn over there, is you've got 20 meters to exchange the baton between the two blue lines. You stand at that red line. That's called the acceleration zone. You are allowed to accelerate from there, and within the two blue lines, you're allowed to exchange the baton. And we would have spent 6 months working on where that little other mark is, what's called a check mark. So when the athlete coming into me hits that check mark, I start. Now, that's not a very scientific way of it. We used to start off walking back 30 steps and practicing it until we got it right. If you had a scientific way of doing it, you could ensure that the batons exchange at maximum velocity every time. Why is that important? The difference between in 2000 Olympics, South Africa won the Olympic silver medal. We were 16th. We actually did well. But the year before and the year after, individually, we beat all of the South Africans. But they had spent a year in training camp working on their baton technique. So you can make huge inroads into it if you work on it really hard. So the Italians spend the year together. They're all in the police. And they all train together the whole time. So if we could use technology to help us, because we have a limited amount of time to get it right, that would be a huge advance. Hasn't been done yet, just something I thought of. Anybody want to do it? I'd be really, really grateful. How can it impact my coaching? So one of them is the relays. I work with some relays, but just really quickly, and I won't keep you much longer, is the information part of things. So I live in Limerick, I work here in Galway, and when the summer comes, this is where all my athletes are going to be. Okay, most of them are just, you know, club athletes or whatever. There's a couple that are a much higher level. One of them is living in Dublin, Fiona, the girl here. Fiona lives in Dublin. And she is hoping to make it in the Irish 4x400 metre relay team to London. So they've half qualified. They have to run another time this year. The other girl, Emily, is also trying to make the 400 metre team. They probably are competing against each other, although I wouldn't say that to them, for a place on that team. They both have very similar problems. They've been out of the sport for quite a long time. They both are coming back for different reasons. Fiona has had an enormous amount of injuries. Emily has the cutest little 3-year-old in the world, but took 4 years out from the sport to have the cute little 3-year-old and came back training about a year ago. Emily has an additional problem, which is Emily lives in Rosario, Argentina. And since I started coaching Emily 2 years ago, I've not seen Emily. So all of my coaching, and athletic sprinting, you can do it possibly with distance running, but sprinting is very technical and very much about how you manage sessions and speeds and control. So it's really, really difficult. So Emily and all my athletes fill in an online training diary and I get back the data as we're going along. Emily's not the greatest with it. And her timing's a bit odd. She should have probably broken the world record off one of the sessions she did last week. She ain't going to do that. Oh, this is going on the internet. I shouldn't say that. Emily, you will. It's okay. But it's difficult. If you're there on your own in a track in the middle of Argentina with no one to train with, no coaches there, and you're using a stopwatch yourself to start you off. So a GPS unit would be great for her. And if the cost comes down, it's something I'll suggest her, and she stays competing next year. And I would love to build up a profile of her training sessions. So Emily will send me back a training session like, I'll show it to you in a second, her training session from last week. And if I built up a profile over time, I'd know how her training's going, really, much more accurately than I do already. And it's quite difficult to just get bare times off someone. If I had a profile of, well, is she fatiguing really a whole lot? Is her maximum speed good? How's her strength? You know that profile I'm talking about there? If I had that for every training session for Emily, I'd be able to coach her a lot better. I'd be able to send her more appropriate sessions. It's also a group thing because not only I look at her sessions, her strength and conditioning coach looks at her sessions, her physio looks at the sessions, and we all together try and do this from a distance. We're all in Ireland and she's in Argentina. And we're trying to build up a performance profile for Emily. We know what she can do, but we need to know what we're doing for her over the next time. And just, again, the ease of use. If I use my phone, instantly I have all that data. And instantly it could be, I could watch it instantly when Emily's training in Argentina. The problem for her is she used to go home, mind a 3-year-old, you know, she's tired after the sessions because they are hard, and then she'll eventually get round to writing the diary, which might be 3 weeks later. So it doesn't really work that way. Fiona is a really interesting one because Fiona is a really good athlete and has had enormous injury problems over the years. And we're beginning to think that the reason that Fiona has a problem is that that the injury comes along after a certain amount of work at a certain pace. So the higher intensity work she does, there's eventually a point where her body just goes, thanks, but no thanks. Seem to think it's a really complex something to do with a musculoskeletal tendon junction thing. Don't really know. It's been tried to. She works as a physio or in a physio practice. So the physio looks at her every day, but she'll still go out and find a way of coming up with the weirdest of injuries. One was described to me as a 1 in 10 billion chance of her doing it. And she's done it twice. And if we had, again, that profile of when did she get injured, we could pull back the amount that she does at different times. And building up that profile would be hugely valuable. And they're just two examples, and I could go on, which I have done, on how GPS would be a massive addition to me as a coach, because it would be instantly available to me, and it would give me a lot of data. It's very simple. It's just velocities, but it would be hugely valuable. And I'm coaching remotely, where I could combine it with video technology and see it. And the other thing is, running the 400 is about managing your pace. And a great example, that one's a training session from me, or a race from me. I used to run a lot of relays, 4x4. And you have to teach how to do it. It's a skill in itself, how to manage your pace. And using GPS again, or pace judgment, if you had feedback again from your watch or from a shock or something that you got from it. I ran in 2003 a relay, and I ran 22.5 and 22.8 with the two splits, which is 45.3, which is a really good split. A couple of weeks earlier, I ran 20.9 for the first 200, which is crazy. And I ran 28 for the second split. So it like added up to 48.9, which is crawling around at the level I was at. And again, GPS might be something to help teach pace. We use it with stopwatches. It doesn't really work very well. And it's an invaluable tool as an educator. There's lots of other things. So that's the session that Emily sent me the other day. And it's building up that profile to see what's her speed, what's her endurance like, what's her fatigue profile. If you understand what her fatigue profile is like, then you get a really good idea of what you've got to do in the next section of her training to change that. So look, I've held you long enough. I have loads of things I could talk about, but maybe if you have any questions, I'd be happy to answer them. Okay. Thanks.
How is it initialized?
That's the problem. You mean this?
How do you have to press a button to start it? Or?
On a GPS watch, yes. Now, what I'm saying is, ideally, I would love, if I was to say, can we design something? This starts in a button. You don't want to do that with a sprinter, because that just ruins the profile again at the start. So if it was either remotely started, and then a beep went off on their phone or something like that, or that you could just have, just when they start, that there would be a piece of software that would filter out the bits beginning and end that it would know. So you obviously have it's static, and then there's movement. So from the first movement, it would time from the first movement, and that would come into it. That would be a brilliant piece of software for a sprint coach. Distance running, at the moment, you can program them to give you a countdown, 5, 4, 3, 2, 1, go. It doesn't really work for, because as well, one of the things you do as a sprint coach is you manipulate the recovery a little bit. While I might say to Emily or to any of the athletes, you get 6 minutes between each run. If they're not looking particularly good, you might give them 6:30. You might give them 6:20. You kind of mess it around a bit. So it's better if that would be a lovely piece of software to develop for it.
I was just wondering, at that level, does weight or aerodynamics of something sticking to your arm on your back get into it?
So this, you wouldn't use it. You couldn't. It would just annoy the hell out of you, number one. And again, you want it to be as natural as possible. So yes, this would have an effect. The shoes, my sprint shoes, probably weigh about the same as the phone. So yeah, it would have an effect in training. And obviously, again, one-sided, even though it's small, so sprinters actually develop the two sides of their back differently because they're running in the same direction all the time. And it's a huge injury thing. So, although you can wear it on different sides, obviously, but yeah, it would be an issue. Aerodynamics, not so much, probably more the psychological side of things. But anything else? Okay, thanks very much. Cheers. Good night.